So for our first experience with Max, we're going to be creating a theremin. This is an instrument that we can use an XY pad to control the frequency and the amplitude of an oscillator, kind of like the examples we might look at in class. So I'm going to go ahead and get started, and the first thing we do is we open up Max MSP, and we're going to create a new patch. So we go File, New Patcher. Down in the bottom left, we have a button to lock or unlock our patch. So when we unlock our patch, we can create new objects, we can connect them, and we can rearrange them. So we're in the programming mode. When we lock the patch, we can interact with the objects and play them as if it was a musical instrument. And you can't create and edit and connect new objects when you're in locked mode. So you'll be going back and forth between locked and unlocked mode a lot. You can click the button down here and monitor whether it's locked or unlocked. You can control or command click to lock or unlock. Or you can use a hotkey, Command E on Mac, Control E on Windows. Will toggle between locked and unlocked mode, and you'll do it second nature without thinking about it before you know it. All right, so we're going to get started. The first thing we're going to do to create our theremins, we need an object that's going to create the sound we're going to listen to. So we're going to create an oscillator that's going to generate a sine wave. And the sine wave oscillator in Max is going to be called cycle tilde. So a couple of things to note here. First off is I created a new object by typing the letter N, and that makes a new blank object, and then as I type in, the name of the object is going to autocomplete. And notice I want cycle tilde. That tilde at the end of cycle is telling us that this is an audio object. So this is going to be functioning at audio rates. We're going to be listening to the output of this object. There's also control rate objects, which are a different kind of object we'll talk about in a second. And just for reference, type C to create a comment box. All right, so we typed N, we create our new cycle object. Now we're going to add a new object, which we're going to use to control the frequency of my cycle object. If I hover over this inlet, I can see it's expecting information about the frequency. So I'm going to type F to create a floating point number and click the bottom of that and click on the top left of the cycle object. So I'm going to option click drag to select that patch cord and delete it, and do that again. So in Max, the inputs to an object are always on the top and the outputs of an object are always on the bottom. And we call them inlet and outlets. So the outlet of our float object, the left one, is going to give the number that's currently entered into that float box. And notice the little pop-up menu tells you that. So I'm going to click it, and then I can drag to the top left object, which is an inlet on the cycle object, and expecting a frequency that's either a signal or a float. So I'm saying float box because we can also type I to create an int box, which, just as you might expect, only can generate integers and not floating point numbers. All right, so now we have a cycle object which is going to be generating the sound we're going to listen to. We need some way to control the amplitude of that cycle object. And in Max, and the computer in generally, we're going to use a times operation to just multiply the output of our cycle object by a constant to turn the volume up and down. So the outlet of my cycle goes in the inlet of my times box. And we're also going to need to provide the times box with a constant, which is going to be the volume. So if we multiply our cycle object times 0, we basically turned it to silence. If we multiply our cycle object by 1, we're leaving it unchanged, so it's full volume. And in between 0 and 1, we're going to be turning the volume down. If you turn the volume up greater than 1, you're amplifying the volume of our cycle object. If you just connect this directly to the speakers of your laptop, it'd be really loud. So we need to turn the volume down a lot. So I'm actually going to make another times tilde box and turn the volume down again. So this time, rather than connecting a float number box here, I'm just giving it a fixed value of 0.1. And this is the argument to this times tilde box. So an argument is just a value that is being used when we create the box to tell it what to do. Notice I didn't create an argument for either of these two objects. By default, if you don't add an argument and it's expecting one, it's going to set that value to 0. So this times tilde box right now is saying, well, whatever comes in, I'm going to multiply it by 0 because you haven't told me what to do. I can tell it what to do by sending in a new box, and that's going to set the new constant to use in the multiply operation. But in this case, I'm just going to manually enter it because we're never going to change this value for this times tilde. It's just permanently reducing our volume by a factor of 10. Now the last thing we need to do is we need to create a the output to your computer. So inside Macs, inside your computer, you're working with digital audio signals. We need to convert that digital signal to an analog signal, which is an electrical signal, which can then get turned into a current to drive an amplifier to make sound coming out of your laptop speakers. So we're going to go from the digital domain to the analog domain. So we're going to need to make a digital audio converter. And in Macs, there's a lot of different ways of doing this, but the easiest way is to type EZDAC tilde, and that's going to create a connection to your laptop speakers. Now, when I hit return or click away from this, you're going to notice that the text is going to go away and it's going to get replaced with the icon of a speaker. And there's two inlets, one for the left channel, one for the right channel. So we're going to click, drag. And now we're not listening to anything yet. So in order to turn audio on and process audio in Macs, we need to enable audio. And there's lots of ways of turning audio on. You can click the speaker icon. You can click down here, or you can go up to Option, Audio Status, and turn audio on and off right there. And audio is on, but we're still not hearing anything. Why not? Well, remember, these objects don't have an argument, so by default, their argument is 0. So we have a 0 hertz sine wave being multiplied by 0. And so in order to hear this, we need to move those into ranges that are appropriate for audio. So 0.1 for amplitude is going to be appropriate between 0 and 1, right? And our cycle object needs to be in the audio range, which is 20 to 20,000 hertz. So I'm going to set it to 400. And there we have a sine wave playing at 400 hertz. If I click and drag here, I can change the frequency of my sine wave. If I click and drag here, I can change the amplitude of my sine wave. If I'm not careful, I go way above 1, it can get really, really loud. So be careful when you're working with amplitude because it can get super, super loud, and you're using headphones, it can be unpleasant. All right, I'm going to set that back to 0, and I'm going to make a user interface for my theremin. So the user interface we're going to use is something called a pict slider. So new object, PICT SLIDER. Now when I click away from it, that pict slider is going to go away and we're going to get a user interface. This is essentially an XY pad, and we have two outlets, one for the horizontal value, one for the vertical value. Now it's important to know that the output of a pict slider goes from 0 to 127. And also they're ints, they're not floats, they're ints. So there's only 128 possible values coming out of our pict slider. These are not the right ranges for our audio, right? Our amplitude should be from 0 to 1, and our frequency, 20 to 20,000 kilohertz is the maximum range, but that's actually really super broad. We actually want it to be much smaller than that. So we need to scale 0 to 127 to the appropriate ranges for these two objects. And there are a lot of ways of doing that, of course, but the easy way in this case is just to use a scale object, and the lower and the higher bounds of the incoming data, and the lower and the higher bounds of the outgoing data. I'm going to make this put a decimal point in here. So the input here is an integer. I want the output of this object to be a float object. By default in Macs, if most Macs objects will work on integers by default, if you want an Macs object to output a float or operate on floating point numbers, you need to manually specify a decimal point in the argument somewhere. And once you do that, it'll sort of converts to floating point mode. So I can connect the outlet of here to there. I'm going to do the same thing here. 0 to 127 is from 0 to 1. It's even more important when you're working with amplitude because you only want to go from 0 to 1. And I'm going to do something special here. I'm going to click, drag, and I'm going to pop this scale object inside that patch cord. So this is a really common operation where you want to insert an object into an existing signal chain. So click, shift, drag, you can sort of pop it in there. It's very convenient. All right, so now that I've done that, I can move my pict slider around, and I'm getting in the right ranges to be able to generate audio. Cool. Now there are a couple of problems with this though. Well, one problem is this. Listen to what happens as I move the volume up and down. Hear that those clicks and pops? So those are discontinuities, and they're coming from the fact that I'm operating these controls in the control domain, and we're controlling an audio signal, which is in the audio domain. So the reason why that happens is in the audio domain, we're processing new samples to listen to 48,000 times a second. And that's determined by our sample rate right here, right? This is how many times a second we have to generate a new output sample. Whereas in the control rate, we're only updating this value when we enter it. So if I type in 0.5, it updates that value when I press return. Or 0, and notice that really loud pop every time I do that. So, so that sudden jump causes a sudden jump in terms of the output of our audio here. And in order to get rid of that, we need to create a smooth line to go from the old value to the new value. And the object to do that is a line tilde object. I'm going to option click drag to select this patch cord and delete it. And connect my line tilde object here. And a line tilde object is expecting a message that tells it what value to go to and how long to get there, right? It's creating a smooth line in the time domain. So the way we're going to do that is we're going to send it a message using a new object called a message box. To create a message box is M for message. And this is a different kind of an object than a regular object. The way you would use a message box is for viewing or manipulating messages or creating messages to send to objects to get them to do what they need to do. So in this instance, we're expecting a amplitude and a time pair, and that time is going to be in milliseconds. So let's take a little bit of a closer look at how this works and what that $ is doing. So I'm going to make another message box, but this one, instead of using the left inlet, I'm going to use the right inlet. And what this is going to let us do is just monitor what's coming out of this box. So now I'm also going to create a float box and send it to the left inlet of this message box. So the left inlet of a message box is going to trigger output and is also going to replace all of these $ arguments with values being drawn from the input message. So in this case, $1 is going to get replaced by the first value that's getting sent to this box, and then we're going to get the whole message sent out, and we'll monitor it in this message box. So there we can see that $ gets replaced by our incoming value, and the 100 gets left alone because it's just a static fixed value. So you can actually have more than one $ messages. Those $ messages get replaced by the respective value in the incoming message. So if I have 3 values in my incoming message, I've got 3 $. $1 is getting replaced by the first value, 2 is replaced by the second value, etc., etc. And we can see what we'd expect. Message $1, 2, 3 becomes message 23, 24, 25. If we only send in one value, that $1 is going to get replaced, but $2 and $3 don't get replaced. Okay, so now we can send our new value we want to go to for our amplitude in here and send this to our line object. And now instead of jumping to this new value immediately, we're going to transition to the new value over 100 milliseconds. And notice this little striped patch cord for audio patch cords versus a plain gray patch cord for control patch cords. So you can always kind of tell which one's a control signal, which one's an audio signal. All right, so let's see if that worked. Great. So no discontinuities there. Now there's another problem we might notice, which is on the horizontal axis. We kind of have the same problem. In order to make this be a little bit more audible, I'm going to increase the frequency range of my scale object. You hear that kind of stair stepping, that kind of like discrete jumps between pitches? Right? So that's happening because this is sending only 0 to 127. Every jump is a relatively large value. To go from 0 to 1 is like a 32 hertz jump down here, right? And so in order to make this be a smooth change between frequencies, we just need to do the exact same thing we did here, where we insert a line object in there, see? And now, we're still getting discrete steps, but we're smoothly transitioning between them so it doesn't seem so dramatic. I'm changing this back to our original value and really get a smooth transition between frequencies. So the last thing we're going to do now, we've created our theremin. It sounds great, works really just exactly like we were hoping it would work, but I want to make a better user interface for this. And Max is great, has a mode called presentation mode, which is great for creating user interfaces. It hides all of the complexity and just lets you rearrange and resize things to make it look really, appealing and comfortable to use. So to use presentation mode, what we have to do is select the objects we want to include. I'm shift-clicking to select all these objects. And then we can right-click any of them and add to presentation. And when we do that, they're all going to have a pinkish outline, right? And now we can select presentation mode down here. Everything else disappears except for the objects that we selected. And we can move these around. And we can... I'm shift, click, and dragging, by the way, to keep the proportions consistent here. Click and drag that. Let's go ahead and move our amplitude and our frequency so they're on top of each other. And let's go ahead and make them so that they're the same size. And then we're going to make them be right aligned. So over here is the inspector menu. Every object in Max is going to have values that you can interact with in the inspector menu. And there's actually a lot of them. Most of them you don't really need to worry about. But if you do need to interact with one of the properties of an object, you can select it, click the inspector box, and a panel is going to open right here. You might need to select all right here to be able to see all of them. There's other options to kind of hide ones that that you don't necessarily use very often. But I always just keep it selected all so it's consistent for me. I prefer that. And I'm going to justify these right. Notice that the text becomes right justified so it's aligned with the number boxes. Okay, so now when I go out of presentation mode, voila, I'm back in my nice and detailed patching mode, and everything's back where it was originally. But when I go to presentation mode, I've got a nice user interface to work with. I'm going to go ahead and go back to my regular full size, position that in the right place, go to my patcher mode, do that same thing here. And now the last thing I might want to do is I might want to make it that when I open this patch, it goes to the inspector mode automatically. So if I want to do that, I need to go to the patcher inspector. So notice my inspector is still open right here. I can close it or open it by clicking I. If there's nothing selected, we can click this P up here and show the patcher inspector. Now this is the inspector for this whole patch, right? So this is their options for their file that I'm saving. And so I can scroll, I make sure all is selected, scroll to the bottom, open in presentation mode. And what this means is when I open this file, it's going to open in presentation mode immediately and not in edit mode like it would normally do. And with that, we are done with creating a theremin in Max MSP.